Before getting into the announcement, it is important to know what particle accelerators are. The Great Hadron Collider LHC at CERN is a 17-meter ring of superconducting material that consists of electromagnets and is the largest and most powerful particle accelerator ever made. It is the pinnacle of human achievement in science. Indeed, because of its extraordinary power, it can accurately replicate the conditions that were prevalent at the beginning of the universe. However, while this device is designed to shed light on the mysteries of the cosmos, it may also possess the potential for something much more troubling. Founded in 1954, CERN is one of the most revered scientific organizations worldwide. With 23 member nations and thousands of researchers, it serves as a hub for cooperation and cutting-edge research. CERN's flagship project is the LHC, yet it is only a portion of a larger scientific network of accelerator investigations. Think of it as a racetrack not for horses or automobiles, but for tiny subatomic particles racing through dimensions of time and space. Protons are accelerated to speeds close to the speed of light, directed toward collisions that reproduce the energy states present at the genesis of the universe. These collisions generate heat 1,000,000 times greater than the core of the Sun. Thousands of magnets guide the particles along their trajectory, while advanced cooling systems keep those magnets at temperatures colder than outer space. Within the LHC, beams of particles are directed to collide at four distinct locations around the ring corresponding to the four particle detectors LHCb, CMS, ALICE, and ATLAS. Each detector has a specific objective, examining different aspects of particle physics. They function like enormous cameras, capturing intricate images of these high-energy events. Researchers then investigate the dispersed fragments, searching for evidence of the Higgs boson, also known as the God particle, as well as other phenomena that unveil the universe's fundamental constituents. By studying the infinitesimal, we learn about the infinite. Yet with each answer, new questions arise, bringing fresh challenges. The LHC is not just a tool for research, it is a symbol of human curiosity and ingenuity. It exemplifies our determination to understand the elements that govern the universe. But as we push the boundaries of knowledge, we must also confront the philosophical and ethical questions that arise. What risks accompany exploring the unknown? Could our discoveries inadvertently release forces beyond our control? Within the prestigious halls of CERN, where human understanding constantly evolves, a revelation has recently emerged, one that even sends chills down the spine of seasoned scientists. Brian Cox, a former CERN physicist and prominent figure in particle physics, recently made a statement that had a global impact, both intriguing and unsettling. His words carried a dreadful weight. The purpose of the Large Hadron Collider at CERN is to recreate a miniature Big Bang. Yes, you heard that correctly. A scaled-down version of the very event that set the universe into motion. Cox explained the significance of this mission, stressing the extraordinary capacity of the LHC to uncover new knowledge. This includes exploring the mysteries of the Higgs boson and investigating dark matter, an enigmatic substance believed to make up a significant portion of the universe. Imagine possessing the power of nature itself, the ability to summon the fundamental building blocks of existence. It is a thrilling possibility, but one fraught with considerable danger. The concept of a miniature Big Bang is no longer theoretical. It is a real-world event occurring within the LHC. The immense heat and pressure recreate the very conditions of space and time at the dawn of reality. However, with such immense power comes immense responsibility. Concerns remain pressing. What if the experiment fails? In fact, history already records a catastrophe. In 1978, Soviet physicist Anatoly Bugorsky suffered a life-altering accident while working at the Institute for High-Energy Physics in Protvino, Russia. A malfunction caused a proton beam to strike his head directly. The light, unimaginably intense, entered the back of his brain and exited through his nose. Bugorsky reported seeing a flash brighter than 1,000 suns, though he felt no immediate pain. The proton beam cut through his brain, damaging bone and tissue, but he remained conscious and even walked to a medical center. The effects were both fascinating and alarming. The tissue destruction left him with hearing loss and partial facial paralysis, yet remarkably, he suffered no mental impairments and continued working in science. His ordeal stands as more than a personal story. It is a grave warning about the risks of high-energy physics. The dangers of the LHC and other accelerators are not insignificant. The potential for unforeseen reactions, possibly altering space and time itself, remains a valid concern among some researchers. One of the most dramatic and unsettling possibilities associated with LHC experiments is the creation of a minuscule black hole. Black holes are regions of spacetime with gravity so strong that nothing, not even light, can escape. They're cosmic mysteries, devourers at the edge of our understanding. The idea that the LHC might create even a tiny black hole is disturbing to both scientists and the public. What if such a black hole grew uncontrollably, consuming the Earth from within? Despite the fact that CERN experts have reassured the general public that any black hole generated would be unstable and vanish almost instantly, the concept alone has ignited intense debate, anxiety, and pondering about the capabilities of the technology. Knowing how a black hole could form entails studying the fundamental nature of particle collisions. The collision of protons traveling nearly at the speed of light can unleash energy that warps space due to its size, the skeleton of a space opera. Consider a trampoline stretched tightly. When a heavy object is dropped on it, the surface flexes, creating a deep depression. If the dipped object is sufficiently heavy, the depression could progress to the point where everything nearby is drawn inward. This is a simplified illustration of what might occur within the LHC. In the strange and elegant world of quantum physics, theoretically, extra dimensions may be hidden from human perception. If so, the LHC's violent collisions could activate them, resulting in a funnel of gravitation that leads to a micro-black hole. This intricate subatomic dance has captivated many prominent scientists, such as the late Stephen Hawking. In his writing, he hypothesized that the Higgs boson, at exceptionally high energies, might become unstable. This instability could cause the decay of the cosmic vacuum, an event so destructive that it would annihilate not only Earth but the entire universe. Sir Martin Rees, a well-known British astrophysicist, also voiced his concerns regarding CERN's experiments. In his book Exploring the Future of Humanity, he outlined the dangers of particle collisions, including potential instability in the vacuum. He did not merely issue warnings, his worries revealed a profound existential apprehension. He contemplated a worst-case scenario in which a flawed experiment could initiate a change in the universe's fundamental structure, setting off a chain reaction that could consume everything in existence. Rees even provided statistical estimates, arguing that even if the likelihood of such outcomes was minimal, the planetary stakes demanded serious consideration. With so much at risk, there was little margin for error. CERN scientists, however, have rigorously analyzed the probabilities, tested countless simulations, and reviewed theoretical models to guarantee the safety of the LHC. Physicist Brian Cox himself emphasized the importance of legitimate investigation. Aware of public uncertainty and concern, he stressed that stringent safety measures and thorough evaluations are in place to ensure the LHC operates with the utmost caution. Cox reassured the public that the energy levels produced by the LHC are no greater than what occurs naturally on Earth. If a black hole ever did form, it would be so small that it would vanish immediately, a phenomenon predicted by Hawking radiation. Such an event would be fleeting, a brief cosmic flash, then gone. Some have speculated even further, suggesting that LHC experiments could rip open a portal to a different dimension or even another universe. Although this concept has been largely rejected by mainstream science, it has piqued public interest and fueled both intrigue and anxiety. What if such a gateway were possible? Could it unleash unknown forces or entities unintentionally? Sensationalized portrayals in the media have even depicted the LHC as a potential entry point into hell, stoking fear and uncertainty. But how did such ideas arise, and do they have any scientific merit? Parallel dimensions are not foreign to modern physics. The leading model, string theory, which seeks to unify nature's forces, suggests that beyond our 3 spatial dimensions and 1 temporal dimension, others may exist curled up and invisible to us. These hidden dimensions could theoretically be accessed under extreme conditions. Now, envision the LHC as a universal key, gaining access to these ancient, secret gateways. When particles collide at high energies, they could push the boundaries of our world, opening portals to undiscovered realms. Even if the chances are extraordinarily small, the mere spark of possibility fuels imagination. Could the LHC be more than a scientific instrument? Possibly even a gateway not just to greater understanding, but to realities beyond human perception. Could this change our view of the universe as a whole? The world pays close attention as the LHC continues its experiments, aware that its potential for discovery is matched by its potential for peril. As we ponder what the Large Hadron Collider might reveal, it is evident that humanity stands at a pivotal crossroads. The LHC is a scientific marvel, a tribute to our insatiable curiosity. It holds the keys to mysteries that could redefine everything we think we know. But with such power comes the responsibility to assess risks, prepare for unexpected outcomes, and address profound ethical questions. The ultimate inquiry remains, is our species prepared for what might lie beneath the surface of the LHC? And if the answer is yes, what will we do with that knowledge? The responses could reshape our destiny in ways we have yet to even conceive.